Uh, the first step is to build an HDL project. Uh, we have analog devices GitHub, and there is an HDL branch in analog devices GitHub. As you see, steps for building a project is explained here. Well, I have downloaded HDL folder before. There are different projects related to different boards and platforms, as you see here. In ADRV9009 folder, there are example projects. Two of them are based on Xilinx ZC706 and ZCU 102 boards. There is a make file inside each folder. There are some TCL scripts here that this make file runs to build a project. I have made project before for ZC706, as you see, and its IPVU project. Obviously there is one zinc block here as a main part, and some other IPs and ports. Let's look inside the design. As you see, two just 204B blocks are here, and the GTX ports are shown in this block. Let's look inside one of TCL scripts now. As you see, the addresses are clear in common folder. There are some TCL files, for example ZC706 underline BD is explaining how our HDL project is created. There are some commands like create port. For example, in HDMI case, we have add IP command and description of its parameters, and the other thing is after parameter settings, add connect command. Add connect describes the way of connections between external ports and the IP ports. These TCL files are useful, and it's good to look inside them for better understanding the project. It's whole thing about this HDL. Well, now we export design to the project folder, and we are done with Vivado software. So I close it, and we need to go to the location of project, and copy the exported design file. It's system underline top dot xsa file. We just copy that and paste it in some folder. Obviously, all these works uh, has to be done after synthesis and generating the bit stream of project. Oh, this was a syntax problem. And memorizing the syntaxes is hard, so I just search the Petalinux document UG1144. Um, Basic syntaxes are explained there. It's very useful document about creating a project. We need the syntax of creating project, and I try to find that and copy the line. This is that line. So I copy this line and paste in the terminal. In the platform, we need to type zinc because our template is zinc, and in the name we can type any name we want to set to our project. There was a problem in syntax. I think we have not to clean name from syntax. So this time the syntax was correct. Second step after creating a project is config. This is the Petalinux config command. And there is a path in this command that points to the location of xsa file. I copy the location of xsa and paste this path in the command and execute the line. Oh, obviously we have to be inside the project folder. I'm trying to correct this line. This time it worked, and it starts to load the config menu. It, it's ready to config different parts that we need. One of them is DTG. The ZC706 is a known DTG for config, and the boot file system has to be set as external. The last thing is Yocto layer setting and user user layers. Now we need meta ADI. This is, as you see, a collection of support layers for analog devices based platforms. It could be downloaded from analog devices GitHub. And there is a table about projects and corresponding platforms. We use ADRV9009 ZC706. You can see an explanation of how to build a project here in this section of this page. Well, I have downloaded from GitHub before. We just copy that and extract it. This is downloaded file. We paste here and extract download meta ADI user layers. As you see in GitHub, there are different versions of meta ADI for download. You just need to know which one is compatible with your Vivado and Petalinux version. I use 2019 release 2. As described in the GitHub page, we need to add meta ADI Xilinx and core addresses. And there is an important note which says the order of adding meta ADI Xilinx and core layers. It's an important thing. So we just copy the needed passes. First one is meta ADI core. The second is meta ADI Xilinx. Okay, now we are done, and just save settings and exit config menu. We say yes and config is done. Mm, it's time consuming, so I stop the video. I will come back again. Well, the config is done. After config, there is a script. It's for setting kernel DTB variable. In the DTS to use, we have to set a true string. Come back again to the table of platforms and copy the device tree name we use and paste that in a script. Now we execute this command line. After that, it's time to build the project. Build time is too much again, and I stop video. Well, as you see, build process is done. Now it's boot time. First of all, we need to package all necessary files. Just copy and paste the script. And it's finished. Okay, we need an SD card to copy files inside. I have attached one to the PC, and you can see my 16 gigabyte SD card with lsblk command in Linux. Its name is std here. Okay, I use cfdisk command for partitioning my SD card. Obviously, it has to set with sudo I need one boot space. 512 megabyte is enough for that. Type of partition has to be FAT32. I allocate 8 gigabyte for rootfs part. Default type is OK for rootfs, and after write command we see two partitions will appear. Both of them are empty, so we go to the project path, and inside the image folder we will find our necessary files to copy inside these two empty partitions. Well, in the project folder, in images folder, we copy boot.bin, image.ub, and system.dtb, and we'll paste here in boot partition. The other thing is rootfs extract this file, and we will copy that inside rootfs. Oh, there is an error. um, Paste command didn't work. It's not a problem. We will figure it out. Mm, well, I think disk manager could solve the problem. In SD card section format and overwrite the 8 GB partition. It's for cleaning that part and it's time consuming. Mm, Now that format finished, I copy files from inside the rootfs folder in the project and paste command is disabled, so we need to change permission. uh, okay, right now easily paste files there. As you see, everything is prepared and it's ready to use, and all the boot files and our SD card is prepared. Well, right now I attached the SD card to the board and use the PuTTY software for connecting to the console of board. The baud rate is set and now we are looking how our OS is coming up. Okay, we can see the logs here. There is useful information here about detecting peripherals like our jest 204B link. Um, we set username and password and these are logs here. Uh, Login is completed and the last thing is config IP. We set a fix IP to the board and we use this IP for connecting to the software that is running on my PC with Windows 7 operating system.